All right, in today's video reference, we're going to learn more about dilations. Particularly, we're just going to focus today on how to find scale factors. So why don't we add that in here? This part of dilation reference is just finding scale factor. So before you just watched the video from Mash Math Up, so Mash Up Math, excuse me. So this will be pretty easy to go through now, hopefully. So the first thing we're going to do is say, look at dilation. So basically, a dilation is one of our first transformations that changes the size of the figure. Okay, so it's just going to change the size, either making it bigger or older, bigger or smaller, excuse me. So basically, when you look at a figure that's either become bigger or smaller, enlarged or shrunk, way to kind of keep it apart is your old original figure is your pre-image, and your new figure is your image. Okay, so mathematicians had to figure out some type of notation to show the difference between the pre-image and then the new image. So basically, image uses the same letters as the pre-image, but you insert a prime notation, which is an apostrophe after the letter. So angle ABC is dilated after a scale factor of blank to produce A prime, B prime, C prime. So can anyone tell me, looking at the two figures here, what do you think the scale factor is? Yeah, I would say a scale factor of 1. They stayed the same. So again, from here to here, if I took, I don't know, pen cap here, looks like it's a little bit more like that. And to there, it's about the same here. So it doesn't change size, it looks like in this example. So how to dilate a figure, which we'll do after our quiz. So scale factor, in math, we use the letter K. Scale factor is a number that you multiply all the coordinates of the pre-image to enlarge or shrink it, giving you the image. All right, so going back to the video you just watched, if K is greater than 1, what's going to happen to the figure? It's going to enlarge. If it's equal to 1, stay the same or equal. And then what if it is, let's see here, greater than 0 but less than 1? So that would do what? Shrink it. So an example of that scale factor might be 1/3, so on and so forth. So one big thing about dilations is this comes up all the time. It's a real big concept that we really have to understand before our test and our quiz and MCAS, is that if you dilate the figure, it's the only transformation. If the scale factor is bigger than 1 or less than 1, it will always be blank to the pre-image. Someone pause the video here, and I want you to talk to a neighbor. Is going to be congruent, similar, neither similar or congruent, or both similar and congruent. So again, the scale factor is bigger than 1 or less than 1, but it's not equal to 1. So hopefully talk to your neighbor and you said B, they're similar. So let's copy that down there. So again, when they're similar, the reason they're similar is because if you perform these scale factors, you're either going to go enlarge or shrink. So you're not changing the angles, you're just changing the size, and that's the very definition of two figures being similar. All right, so now let's focus on how to actually find scale factor. So I'm going to pause the video here, and this part of the notes is going to be brought to you by Tanya. Tanya is a woman that does a YouTube video, and she's Southern. So can someone tell me, what is this letter right here? Hey, you probably said L. But how does she pronounce it? She pronounces it as L, letter L. So L. don't know how you'd even write that. Eel. So enjoy the video. We'll learn how to find scale factor, and then we'll go from there. All right, so hopefully you watched the video, and basically to find scale factor, you're going to take your new, which is your image, divided by your old, which is your pre-image. So in other words, it's new divided by old. And what acronym did you use? What did you use to help you remember new divided by old? No. All right, great. Let's turn the page and look at the last part of today's notes, which is actually practicing finding some scale factor. For today, I think we're just going to look at, because we're really going to get into coordinates more in the next part of the unit. So let's just focus on method 2, which is finding the corresponding side lengths and dividing new divided by old or no. So example A. So here, again, they are on the coordinate, but you can just count the side lengths by just counting the different units. So for example, this AB is 1, 2, 3. So I'm going to write here 3. And then what does that correspond to in the other triangle? Yeah, it corresponds to A prime, B prime. Okay. Can someone tell me how long A prime, B prime is? It's 9. Okay. So, what is our division problem going to be when we do our formula? And we're just looking at these two side lengths, new divided by old. So new divided by old. Are we going to do 3 divided by 9? Or are we going to do 9 divided by 3? Yeah, we're going to do 9 divided by 3. So again, this is your new. This is your old. Because again, these have the primes. So common sense, if you just think about it, if you're going from old to new, the scale factor should be bigger than 1 because you're going from smaller to a bigger figure. So what is the scale factor? 3. Great, let's do one more here. So before we even start this one, again, we're not going to pay attention to the coordinates. Really just going to look at the side lengths. Can someone tell me what is the new figure? Is it the smaller rectangle? I'm sorry, the bigger rectangle or the smaller rectangle? Yeah, it's the smaller rectangle here. You knew that because it was primes, so we'll put here new. And the old original figure is out here. Let's start with, we could really do any two corresponding side lengths. I'll just use, let's see here, the 2 CDs, if you will. So CD, and then the CD here. Okay, so can someone tell me what's the length of my new? I do new divided by old. Yeah, it is 1, 2, 3, 4. And then what is my old side length? 1, 2, 3, 4, 5, 6. Can anyone tell me what 4, 6 simplifies to as a fraction? Yeah, 2/3. And let's ask ourselves if this may make any sense. So old to new looks like it's getting smaller. And here our scale factor, K equals 2/3. That is less than, so our K here is less than 1. It's, of course, greater than 0. So this does make sense. Great. Hopefully this helps you find scale factor. Again, the key is, for now, we're not going to worry too much about the coordinates. Just looking at the side lengths, count up those side lengths if it doesn't tell you, and take the new divided by the old. And just one more time, can someone tell me, how do you know which figure is new? Yeah, the prime apostrophe notation. That right there gives it away.